Hi everyone, in this video we're going to discuss about integration by parts. So for integration by parts, we will express our integral into two parts where the first part is u and the second part as dv. So from the u part, we are going to differentiate in order to get du. For the dv part, we are going to integrate so that we can get back what is our v. By using this integration by part formula, integrate u dv, it will be equals to uv minus integrate v du. The idea is to choose u and dv from our questions, and the priority to choose u is followed by this sequence, which is log pad. First, we will choose u for logarithm. This is our first priority, followed by polynomial functions, followed by exponential functions, and lastly, it will be trigonometry functions. Once our questions is chosen by u, the rest of the part of the question will become the dv. Then you can start do the differentiation to find what is your du and do the integration to find what is dv. Lastly, we only integrate for this part only. Integrate v du. So therefore, you can see from the fun questions, you can separate it by two parts and only integrate this part. So we call it this technique as integration by part. For example, by using integration by part, find the following question 1. Integrate x e x dx. Notice that our functions here is polynomial x and another function is exponential functions. And for this question, we cannot use our formula because e to the power of fx is supposed to have 1 at here. Integrate ex, we can integrate, but we want to integrate ex. We cannot integrate by formula. Therefore, we will apply our integration by parts. So for normally integration by parts, we will meet two different functions like this. For x, this is polynomial functions. Meanwhile, for ex, it is a exponential functions. So we will start our integration by part. First, we're going to decide which function to be u. So we will choose u by following this order. Do we have logarithm functions? No, we don't have. Do we have polynomial function? Yes, we have a polynomial function which is x. Once our questions decide the u as a polynomial function here, the rest of it will be represented as dv. So the rest of it will be ex dx to be equals to dv. So from the one question, we have to identify two parts. The first part is u and the rest of the part will be dv. So how to choose your u? You must follow by this sequence. So after we identify our u and dv, for the u part, we are going to differentiate in order to get du as shown in the formula here. So for u, we will differentiate u with respect to x, then we get 1. Our motive here is to find out what is our du, which is equal to dx. Then, by looking at this formula, u we have already, du we found already, now we're going to find our v. So how we're going to find our v? We will integrate the part of dv. dv equals to ex dx. I rearrange the order. I start with dv, then equals to the rest of the function here, ex dx. So for dv, how do I get v? I can integrate both sides. So when I integrate constant of dv, 1 dv, actually inside here is 1. When I integrate 1 dv, our unknown is v, so it will equals to v. When I integrate ex, so we will get ex. Therefore, I remind again, we must very familiar with our formula that we learned before in 1.1. So for here, we will hold on to plus c first. We don't need plus c first because our integration haven't finished yet. After we get v, we can substitute into our integration by part formula. Rewrite our questions so that this is equals that uv, which is x times ex. So the formula will be uv. So this is our questions, equals to uv minus integrate v du is dx. So follow the formula given. So for this ex, they already simplified. Now we only integrate this part only. So that's why this technique we call it integration by parts. So for here, when we integrate ex, it will give us ex. Finally, after we integrate everything, then only we plus c. Then for question 2, integrate ln x. As we have integrate 1 over x to equals to ln, but we never have integrate ln x. When the question asks you to find integrate ln x, we will need to use integration by parts. Therefore, first step, we are going to identify what is our u. Our u will be log pad u. We will select the functions in the order log, polynomial, exponential, and trigo. So from here, we only have logarithm function, so u will be equals to ln x. And then the rest of the part is equals to dv. So dv will equals to dx, because when we let u to become ln x, and then this part will become dv. For the u part, what can we do? We will differentiate u with respect to x, then differentiate ln x, we will get 1 over x. So we want to achieve du. So du will be equals to 1 over x dx. How about dv? dv we will do the process integrate both sides, where inside here is 1, so integrate 1, it gives you v. Integrate 1x, it gives you x. So our step haven't finished yet, so we won't plus c here. In order to finish our integration by parts, we have to put back our questions. This is our questions. This is equals to uv. So I will times x ln x, because my u is ln x, my v is x, so I will times x in front of here to avoid confusions. Then continue, we will minus integrate v, which is x, du, which is 1 over x dx. Plug in the information for u, for v, and then for du. After we plug in the information here, so this is our part that already simplified. We just need to integrate for this part. So x times 1 over x, we can simplify, leaving 1. Therefore, integrate 1 with respect to x will give us unknown of x, then plus c. For next example, we are going to integrate x cos 2x dx. So for this question, you can see very clearly our function is mixed functions, where the first function is polynomial x and another function is cos 2x. So in order to integrate this by integration by part, we have to identify which is our u, which is our dv. So u will follow the priority of log. We don't have log pad, so polynomial, yes, we have an x here. Therefore, when I select this x to be our u, the rest of the part here, it will become our dv. So cos 2x dx. For u part, we will differentiate u with respect to x, which is equals to 1. Therefore, we need to find du, which is equals to dx. Because our formula, we need u, v, du. So for dv part, we will integrate both sides. So when I integrate, inside here is 1 dv. So this is unknown v, therefore I will get v. Integrate cos 2x. So when you have integrate cos 2x, you will get sine 2x. Then over the angle of the 2x here, coefficient is 2. Then we plug in our integration by part formula where u times v. So x sine 2x over 2. This is our u times v minus integrate v. This is v du. Du is equal to dx. So how to integrate this? First, we simplify the 1 over 2, we take out. Then we only integrate sine 2x with respect to x. So when we integrate sine, it will give you negative cos. I hope that you're familiar with your formula already, where your angle here 2x is divided by 2, then plus c. Finally, simplify our answer by expanding this negative 1 over 2. So negative times negative, positive 1 over 4. Next, we're going to integrate 2x e negative 3x plus 1 dx. So we can see here 2x is polynomial, and then e3x plus 1 is exponential functions. And then now we want to integrate by parts. So first, we will select what is our u, and the remaining part of this question will become our dv. Polynomial versus exponential, log back. Log don't have, polynomial, yes, we will select 2x as u. And then the rest of the part will equals to e negative 3x plus 1 dx. Therefore, for u, we will differentiate u with respect to x, which is 2, and we need to obtain what is du. This is 2 dx. Meanwhile, for dv, we are going to integrate both sides, so this is equals to v. For integrate exponential, copy back the questions, then divide by the coefficient of the x, which is negative 3. Then we write back our questions because we want to show these questions can be integrated by parts. So the first part is uv here. So it will become 2x e negative 3x plus 1 over negative 3. And then minus integrate v. So this is our v du. Du is 2 dx. So notice that when we apply integration by part, from the question that is very hard, we cannot integrate anything, then we will become a question that very simple, that we can integrate just by formula. So for this part, we can factorize out our 2n over negative 3. It will become positive 2 over 3. We just integrate for e negative 3x plus 1 dx. Integrate exponential, so copy back the questions and then divide by the coefficient of x, which is negative 3, then we will plus c. So 3 times 3 will get 9. So the next we're going to integrate 2 plus x squared ex dx. This is our polynomial quadratic, and this is our exponential functions. So when we want to integrate this is a mixed function. You can see polynomial and exponential is different kind of the functions. We can use integration by part. So for u and dv. So what function can be selected as u? So we will select as L, we don't have. P, yes, we have. So 2 plus x squared. So this will be given priority to select as u. The rest of the part of the question, it will become dv. Therefore, differentiate u with respect to x, it will become 2x. And then we must obtain du because our formula is equals to uv minus v du. So we must obtain what is du. Then for dv part, we are going to integrate both sides so that this one 1 dv will equals to v. Integrate ex, e is equals to ex. Finally, we plug in the information into our questions here, where this question is equals to integration by part uv. So put your bracket to show that this is your u times with your v, minus integrate v du. Du is 2x dx. So these two I can factorize out, and then x dx. Notice that for this question we cannot integrate ex only. We have another function polynomial x in front of here, so we need to do our integration by part again. But for this question, just now we already solved what is our sex in questions number 1. So you can refer back what is your answer for your question number 1 so that we can plug in the answer straight away. So by referring the answer from number 1, when we integrate sex, we get sex minus ex. So plus c at the back here. Then we're going to simplify this answer. Since here got ex, here also have ex term, here also have ex term, we can factorize our ex. And then this part, first term will be leaving 2 plus x squared. For this, we will leaving negative 2x. And then for that, we will leaving 2. So simplify our 2 plus 2, it will equals to 4. So that's all for integration by part. Stay tuned for the next video about integration by partial fractions. Thank you for your time. Thanks for watching.